spend some time to talk to you today about what can influence your calprotectin test before you guys even get to put it anywhere near your analyzers or your assays. Okay? So let's go back to the beginning. We all know that the calprotectin is picked up by the stool as it comes into contact with inflamed areas in the gut. So depending on which type of IBD you've got and the various stages of the disease, it can be pretty much throughout the entire gut. It can be confined to individual segments within the gut, or it can actually be confined to small localized patches in the gut. So with formed stools, or your slightly squishy ones, to a large extent the calprotectin is then going to be confined to the outside of your stool sample, where it has physically come into contact with the inflamed area of the gut, so it's sort of scraped off on the edge. With the liquid stools, being as calprotectin is a soluble protein, you are going to find that they are diffused more throughout the sample that you're going to get. So what does this mean for you? What it means is that in the samples that you receive in the laboratory, the calprotectin is not going to be uniformly distributed. So unfortunately, for you as biochemists, and not like in stool samples, that means you've got to mix, because the calprotectin is not going to be uniform. So ideally you need to mix it, okay, to ensure that you get the best chance of getting any calprotectin that's there if possible. In the absence of mixing, because biochemists really, you know, in my experience of biochemists, they think stool sample is a microbiology test, which is probably where I come from. But in the absence of strict mixing, what you need to do is make sure that you sample from about 3 to 5 different places in the stool, just to increase the probability that you're actually going to pick up some of the calprotectin if it's actually there. So, what type of sample is required? The gut transit time will quite radically influence the concentration of calprotectin that you're going to get in the stool. We know that it's picked up as it's in contact with the stool. If it progresses nice and slowly through the gut, it picks up quite a lot of the calprotectin if it's there on its way through. If the transit time is more rapid, as tends to happen with these patients, then it's going to pick up a lot less calprotectin because it's just not physically there for long enough to collect the sample. So this is a graph that is adapted from a paper by Larson that was done in 2014, and I love this paper. It's a bit of a sort of geek's delight, really. He took a whole pile of IBD positive patients and collected every single sample that they did in the day. So this graph here then represents the, sorry, wrong button. Catching, James, it's catching. This graph here then represents, along the bottom here, individual patients, and as you can see, the number of bowel movements that they had during the day. So you go from a low of 2 to 3 at this end, up to 13 bowel movements for the poor chap on the end. On this level here is then the concentration of calprotectin that were in those stools. The pale blue line being the highest level recorded in that single day, and the dark blue line being the lowest level. As you can see, the difference in the calprotectin levels within a single patient in a single day is extreme. You have up to 12,000 as a high here, going down to probably only sort of 200 or 300 at the bottom. So for these patients where they have really, really high calprotectin levels, although the difference is extreme, they do still at least stay positive in their calprotectin level throughout the day. The poor patient on the end here had a high of just over 800, which is still quite a significant calprotectin level, but he went to a low of 24, which doesn't matter whose assay you're using and what cut-offs, is a complete enough to negative in everybody's category. So as you can see, what sample of the day, that was an interesting question, I thought, what sample that's being taken actually can strongly influence what the result is you get out at the end. So that leads to the question as to what advice you're going to give to your patients about which sample is the most appropriate one to collect. So ideally, we always say that it's the first sample of the day, and the reason for this is because it's been in the gut overnight, it is likely to contain the highest level of calprotectin in the day. Urgency can be a bit of an issue for these IBD patients, so I appreciate that the first sample of the day is not always possible. If you're not going to take the first one of the day, it does at least need to be one that is not too soon after the previous one. So if you've only been 10 minutes beforehand, don't then collect the next one. Try and leave a good couple of hours between when the last one was, so that the sample has a chance to collect calprotectin if it's actually there. The other rules that apply to your patients is obviously that the stool must not come into contact with the toilet water. Okay, that's going to contain bleaches and disinfectants, and it will impact your test. Okay, so there's any number of ways that patients are quite ingenious, really, that can collect the samples. There are lots of collection devices available to help people if they want to. I think someone mentioned earlier with the fecal collection devices and the papers that are handed out with the bowel screening things. Possibly not so appropriate in your IBD patients because they're not robust enough, more asymptomatic than you're symptomatic, you see what I mean? But cling film has been used, obviously loosely draped, not tight, so that you can collect it in the side, in the dip. You can have clean takeaway containers, or actually plastic bags are actually quite useful because you can drape those over the toilet seat again with a dip, so that you can collect it and then obviously dispose of it afterwards. And the other thing that patients need to really remember is they mustn't get it contaminated with urine, because if you've got a liquid sample, all you're doing is effectively diluting the level of calprotectin that's in there. So that is another critical one, is they must avoid doing that. The more advice to patients that I would suggest you give is that actually what they need to do is to half fill the container provided. I mean, we've all been there with that container that is so full that it is bulging and leaking, or if not actually physically leaking when you're getting hold of it, it is so bulging, it's pressurised that the second you touch it, you know it's going everywhere. It's unpleasant. We don't need quite that much of calprotectin, of stool sample, but the other extreme is that the small little tip on the end of the spoon that's quite often provided is really also not helpful. As we've said, calprotectin is not uniform within the stool, so if they only give you a little bit, you've got a high probability of not having any of it in the sample in the first place. So they're not giving you the best chance of isolating it. I think some of the problems that comes with doing the calprotectin in the laboratories is the pots that are provided. And I think the tall, narrow neck pots with the spoons that are provided are not necessarily overly helpful. You might think, okay, the spoon's there to help put it in, but it does encourage the patients to actually give you that tiny little tip off the end of the spoon, and that's all that you've got. So, and I think the laboratories tend to use these pots because, you know, historically biochemists haven't necessarily done fecal testing. When you're having to do them back in the laboratory, you're looking around and thinking, oh, what pot have I got? I know, the microbiologists use this pot, and that's fine, because in microbiology, the stool is absolutely hotching, and so it's completely fine to have that tiny little tip, but for biochemists and calprotectin, you need more than that. If you are going to do the strict method of mixing the sample, with that narrow neck, you're not really giving yourself much opportunity to do that with. And again, if you're not mixing, in which case you need a sample from 3 to 5 places, again, with that narrow neck, it's making your lives extremely difficult. I think, given a choice, if it was me and I had the opportunity to say what sample pot I wanted, I would be going for these sort of small, squat, bigger necked containers that actually allow you better access to the stool sample. Sample consistency. Sorry, glad we finished lunch. I do apologise for this one. Ideally, for calprotectin testing, what you need is what we call the Nutella portion of the stool. Okay, so that slightly soft, squidgy part of the stool is the ideal part that you're after, to be honest. Food particles really should be avoided at all costs. The thing is the calprotectin has come from the inflammation that's created, it comes from your body, okay? Whole grains and fibres come from your food and have nothing to do with the calprotectin, so they are not going to contain anything. If you're doing strict manual weighing method, you have to be very careful not to include those. It's easy to include the whole grains and the fibres when you're weighing. They will contribute to the weight and therefore of what you're doing, but they will not contain any calprotectin. That is one of the better advantages of the extraction devices is that if you're using one of the extraction devices, it's less easy to accidentally get the fibres and whole grains in there, so you do avoid that bit. If you've done any extensive stool testing, you will have come across the complete gambit of stool consistencies that there is available to us. It's eloquently drawn for us in the Bristol stool chart. But the different specimen types that you get can actually influence the result that you're going to get at the end. So it's worth bearing that in mind. So we have the liquid samples. In actual fact, in a way, these are some of the easier ones to handle because at least the calprotectin is usually fairly evenly distributed throughout, so there's no issues there with the mixing. You can do the manual weighing with the liquid method, but if you're using some of the extraction devices, usually the advice from manufacturers is A, don't, or B, you can actually pipette the appropriate volume into the extraction devices. And the reason for this is because all the assays that everybody's using, they are quantitative assays. And so in order to get a strictly accurate result, you need to put a designated amount into the sample. Okay, so that's why they do that protocol. There are lots of laboratories who do not want to employ multiple different methods really for different sample types. If they're going to do a process, they want to do the same thing each time. So people do use the extraction devices as they normally would with any other sample. And it is possible you can get reasonably good correlation. The thing that I would say is that you will only ever get a lower result, if you see what I mean. There's a reasonable correlation, but please be aware that if you're going to do it like that, you can get a slightly lower result. And be aware that all the extraction devices don't cope with being used in that way in the same way. Some of them, because the grooves are quite close together, the surface tension will hold the liquid fairly well, and that's why you get a good correlation. But some of the extraction devices have the grooves pretty spaced apart, and those are going to be sort of quite fairly poor if you use them in that way. Some of the other extraction devices have the grooves more in a spiral, and that would be proper shocking to use. It's not going to hold the liquid in any way, so yeah, don't do that way. And as I say, the results that you're going to get if you use the extraction device like that will be slightly lower than if you're going to strictly pipette or weigh the result out. The hard samples. We've all seen it. Clinical symptoms says they've had diarrhea for 4 weeks and the only thing they managed to produce for you are these hard little bullets that look like rabbit droppings. These are some of the more challenging types of stool to actually deal with from your perspective, because A, you have to mix them, well yeah, try that one, or weigh them out. You've got to try and squish them into split the samples in half and try and get them the exact amount you need into the weighing thing. Or if you're using the extraction device, stabbing them once is challenging them enough. Stabbing them 3 to 5 times is particularly difficult. The problem you have is that calprotectin and hard samples can still be calprotectin positive. I was at a hospital the other year where the gastroenterologist told me that in the hospital that he was in previously, hard samples were rejected because they can't be positive because they're hard. Well, in actual fact, that's not true. This table is taken from a study that was done in Scotland, where they tested 147 routine samples, of which 10 of the samples were classified as hard. And as you can see, 2 of them were negative, 4 of them were classified in the grey zone, so somewhere between 50 and 200, and you had 4 that were positive. In actual fact, 1 of them greater than 1800. So you cannot just disregard your hard samples and say, well, they're clearly not positive, they are. And I do appreciate that in actual fact, they are a really quite challenging sample to do. And if it was me, I would try and trap them against the side of the container and squash them, because if you try to stab them, they're just going to ping around the lab, which is not good. Mucoid samples, another one of the favourites. They're very difficult, challenging samples to deal with. what we can say is actually, if at all possible, avoid the mucus, okay? Quite often it can be hard with mucoid around the edge. Again, as I say, just avoid the mucus, or sometimes you can get really liquid ones. They're mucoid and liquid. If you get the option, go for the liquid, avoid the mucus, okay? The glycoproteins in the mucus can bind to the calprotectin, and so they will cause the result to be artificially low. Okay, this is one of the things where actually, you know, a lot of data on there is, I think, quite a lack of data on the pre-analytic issues that we're talking about here. Certainly on the mucoid sample, there is very little sort of data that you can have a look. But this is a graph that was taken from a poster that was shown at Focus this year. And they took 2 mucoid samples, one with a high calprotectin level and one with a low calprotectin level, and they deliberately sampled in 10 different places within those stools. I mean, the low one doesn't really vary much. There was no calprotectin there, there was no calprotectin. It didn't really make any difference whether there was mucus or not. But your high ones here, I'm sorry you can't actually see the scale of this, but you come to a high, really probably of just under 4,000 micrograms per gram, and you end up with a low of about 1,700. So more than 50% has changed because of the mucus that's in there. Bloodstain samples. Now, I know that lots of labs will reject bloodstain samples because of the risk of the blood causing a false positive result. Now, calprotectin levels in normal blood is probably only around 1.2 micrograms per mil. The calprotectin level in an active rheumatoid arthritis patient is probably going to be on an average of around 6 micrograms per mil. So, if we're taking the standard cutoff values, calprotectin, fecal calprotectin negative is less than 50, and positive is around more than 200, which means that you're going to need 150 micrograms per gram of additional calprotectin from the blood to cause a false positive. So that means you're going to need 25 mils of blood per gram of stool from an active rheumatoid arthritis patient, or 125 mils from a healthy patient to cause a false positive. And I think if the patient's bleeding that much, they've got more wrong with them than just, they might have IBD or IBS, and they refer that instant referral to the gastroenterologist. So I think, in all honesty, yes, it can impact your results, but it is still better to test the result and say, by the way, it's blood-stained, and so therefore the clinician can have that information and can make the judgment for themselves how much they think it might have impacted. So in summary, on the stool consistency, it can impact your result. So you need to understand how you're dealing with these different samples. And personally, I do think it's better to analyse the samples and to make a comment regarding the consistency and what potential impact it's had, rather than to reject the sample. And some of the questions that we've got up on the walls have actually been trying to understand what information and guidance you guys in the laboratory are potentially given to the clinicians if they are either testing or not testing those results, and potentially what impact those things are having. So what we'll do at the end is we're going to collate all the answers that everybody's got, and well, we've got all your email addresses anyway from when you signed up. So we'll be able to send that sort of information back out, which I think will be quite interesting for people. The thing is, as I say, a positive result can be acted upon. And a negative result with a comment can then be left to the clinician's judgment as to what they want to do, whether they think it's going to be impacted. If the symptoms still remain, then they can repeat if they want to. But at least you've made a positive impact on what can be done for the patients. Calprotectin stability. Now this is really important, especially if you are either using or operating a referral service, or if you are sort of batching your tests and only testing once a week. You need to understand really what the stability of the product, the calprotectin is in the samples that you're receiving. There was quite a lot earlier about the stability of the fit things. It's exactly the same with the calprotectin, although personally I think, again, there is very little information out in the literature. If you look at it, it usually states that the calprotectin is stable in faeces for 3 days at ambient and 7 days at 2 to 8. Invariably, there is little to support that, it's just a statement. If there is something to support it, it can often be a little bit sketchy, I think. this graph is actually from the same paper by Larson in 2014. And they stored samples, stool samples at ambient, tested them at day 1, day 3 and day 7. And the overall conclusion in the paper is that the calprotectin is stable at ambient for 3 days and not at 7 days. However, if you look at the detail of some of these, some of the samples lose between 30 and 50% in a 3-day period. And you might say that, okay, all those samples were very high, those samples that I have highlighted here, they're very high and they stay high as well, even throughout the day. So is it not just slightly academic that you've lost probably 50%? And if you're monitoring, you might, unless you're monitoring, you might just say, well, it was positive, it was positive, it was positive. But if you look at this sample here, oh God, I can't, I'm shaking. I'm going to do it with my finger. This one here, you probably can't start off at around 500, and it goes down to what? Maybe a couple of hundred? Not quite sure really. I mean, 500 is probably, not trying to take away the thunder, but probably a figure that you might act upon as a gastroenterologist. I would have thought that, you know, that's a level as far as I would suggest that they would act upon, down to maybe, even if it only goes down to 200, it might still be positive, but would you act on it immediately? Possibly not. You can't actually see, unfortunately, in the paper what the actual values are. You've just got the graphs, which is a little bit of a shame. But really, even, you know, that level does drop quite significantly there. So that's storing samples at ambient in the stool. So then we have these graphs are from a poster that was shown at Focus this year by Evans. And what they did, I've adapted these graphs from the data that they presented in the poster, and they took only three samples. So sorry, it's a small data set, and that's what I'm saying about the literature. Is there's very little data out there that you can get your hands on. They took 3 samples and they stored the stools at ambient and tested them on day 0 and day 3. And as you can see, there's quite a reasonable drop-off in the calprotectin level over that time period. They took the same samples and then they put them in the fridge. And as you can see, they then tested it at day 3 and day 7, and they have arrested the degradation, but there's still actually a reasonable amount of drop-off there. They then froze the samples in the stool before testing at day 3 and day 7. And as you can see there, that's obviously kept the samples fairly stable. Now this is all in the stool. They then extracted the sample on receipt and then stored them in the fridge and tested at 3 days and 7. As you can see there, that the extracted samples are way more stable than the calprotectin in the stool samples. And to be honest, that doesn't really sound surprising, because the matrix in which the calprotectin is hugely variable. So even when you do get the odd bit of data that says overall it's stable, because the matrix is so infinitely variable, you can't really predict that actually what each individual stool, or the calprotectin in each individual stool, is going to be stable, because there's so many different influences on it. So extracting it, I think, is probably the better way forward. If you're going to batch them and store them, I think extracting them and then storing them is the better way forward to go. However, it might not be the complete picture. This is a graph that was taken from a poster that was done at DDF in 2015 by Simon Whitehead. And it was part of a set of samples that were sent out and done through the EQA scheme. And what they did was they took 3 samples. They ensured that they were homogeneously mixed by sacrificing some kitchen blenders. They then stored them. In the fridge and at ambient for 7 and 14 days, and then they pushed them out through the EQA scheme. You lucky people getting that. And these graphs then show you, this is the baseline. You then have, this is ambient at 7 days, ambient at 14 days, fridge at 7 days, fridge at 14 days, and the second baseline. Now, each of these different lines represents a different manufacturer on the EQA scheme. So it's not just about how you stored the sample. The stability appears to then be related to which assay you're then putting it in at the end. And as you can see, some of them cope better than others. So it's possibly not just the storage, but the assay that you're going with it. So, bearing in mind that this is a stool sample, and we said back from this one that storage in the stool is not the best option, how about if we look at if they'd stored it in the extract, maybe you would have got a better thing. This is a paper that has been published in the last couple of months, actually, and they took 55 stool samples and they extracted them into different manufacturers' buffers. And then they tested them at obviously day 0, day 3 and day 7 in the individual manufacturers' assays. And as you can see, this here is the mean difference in the results between those two tests. So as you can see, some are fairly stable between the things, and some have quite a lot of degradation still. So even extracting them into the buffers and storing them into the fridge is not necessarily going to help. From the first graph, we saw that freezing obviously potentially was the best option. So in this paper, again, they then froze, they did the same experiment, but they froze the samples. So this is the extracted frozen samples, and a lot more of them are stable on that basis. However, some are still actually proper shocking. I'm not going to say who they are anyway, but yeah, so it certainly it's potentially something that you might want to look at with your own assays and your own techniques as to whether or not your samples are stable for what it is that you're doing. So in summary, I would just like to say that beware of the factors that can influence the test before you even get your hands on it. Specifically how and when the stool is collected, the sample volume that you're going to get, and the sample consistency, and obviously the transportation time and temperature. And that is it.